Algebra 2 state sample question number 2. So functions f, g, and h are given below. F of x is sine 2x, g of x is f of x plus 1, and h of x is this graph. Because a function can be represented several ways. The most common are with the equation graphically or a table of points. And they want to know what's true about these functions together in relative to, are they odd, even functions, and so on, so on, so on. So we really need to know pretty well the difference between an even function and an odd function. So let's review that real quick, and then we'll take a look at each of these and see what we believe they are. So an even function and an odd function. So an even function, there's a couple of things. Now, first of all, an even function has all even exponents. If we're looking at it in terms of like x squared, all even exponents. For example, um, y equals x to the fourth plus 3x squared minus 7. And you might say, wait a minute, 7 doesn't have an even exponent. But it could be thought of as kind of like x to the 0. And that does apply. So even functions can have what's called a constant. A constant is a number without a variable attached to it. So it has to have even exponents and constants. So all even exponents plus or minus constants. It doesn't have to have constants, but the one thing it can't have is an odd exponent. It can't have an x to the first, x to the third, so on, so on, so on. Odd functions have all odd exponents. So, for example, y equals x to the fifth plus, 2x to the first. Odd exponents only. 1, 3, 5, 7, so on, so on. So this cannot have even exponents, 2, 4, 6, and it also can't have constants. Now, they have to be even degree, meaning the highest exponent is even, and this has to be odd degree, the highest exponent is odd. And that means that, graphically wise, an even degree means arrows are pointing in the same direction in the end, either both up or both down. Odd means you get, one arrow in one direction pointing up, one arrow pointing down. That's odd degree. Odd function requires more than that. It requires a type of symmetry. Same thing with even function. So you can be an even degree, but not even function. It could be neither. Same thing with odd. It could be odd degree, but not odd function. So it's all about the symmetry. So for an even function, this is really going to test my art skills here. For an even function, it has to be symmetrical on the y-axis. It has to reflect across the y-axis to be symmetrical. We use lowercase r for reflection, right? Remember your geometry. So reflect the y-axis symmetry. We have to see a mirror image when we reflect horizontally across the y-axis and no other axis. That's what an even function looks like, much like h of x. This is an even function here because it has that y-axis symmetry. It looks like a mirror image of itself. An odd function has a different type of symmetry. An odd function has what we call rotational symmetry through the origin. And rotational, we use capital R for rotation. It's got to be a rotation of 180 degrees through the origin. And what that means is if I take this graph here and I flip it upside down, it looks the same. So if I rotate at 180, but rotate at 180 about the origin, which is the key. It has to be the point of rotation, has to be the origin. So that's what an odd function looks like graphically. Now when it comes to trig, the even and odd functions, the sine curve, we know sine function, if I were to draw, say, sine 2x would look like this. But we also need to look at the other side of it here, and it would look like that. This curve here, let me trace this part of it. That is not symmetrical on the y-axis, but if I take that sine curve and flip it upside down 180, pivoting around this origin, my art's not perfect, I see it does match. So the sine curve, the basic sine curve, when the midline is the x-axis, that basic sine curve is an odd function. So sine of x is in the odd function category. And cosine of x, if we look at the cosine graph, The cosine graph looks like that, but we see it on the other side too. The cosine graph is symmetrical on the y-axis, so the cosine function is an even function. That's probably different than what you would guess. You would probably guess sine even and cosine odd. I don't really know why. At least I would anyways. But once you get to know them, it's actually cosine is even and sine is odd. So this function here, sine 2x, this is an an odd function. However, sine doesn't guarantee that it's going to be odd because there's different things we could have around the sine. There's a difference between, 2 sine x, sine 2x, sine x plus 2, things like that. Now, changing the amplitude, which would be a number here, or changing the frequency, which this number does here, that doesn't change the symmetry about the origin. It's still going through the origin, it's still symmetrical. The only thing that would really change the sine and cosine graphs to not be even and odd is a translation. Moving it side to side could change it from, one to the other as far as even and odd goes. But moving it up and down, that's what kills it. That's what makes it neither, because if you move this thing up, it's no longer centered at the origin and the rotational symmetry falls apart. So this sine 2x is an odd function, but g of x, which is f of x plus 1, so that's basically sine 2x, but then plus 1, and we have to remember what our transformations are. Remember the transformations that, the f of x, plus or minus 1, that is your up-down, and plus is up, minus is down. But the f of x plus or minus 1 in the parentheses, that's your side to side. And the plus is actually left and the minus is right, which is a little counterintuitive. But this f of x plus 1, this means up 1. So that means our sine graph was moved up 1. So again, if you take a look at the sine curve, that's a terrible sine curve. Let me draw a better graph than that. Take a look at the sine curve through the origin. That has 180 rotational symmetry at the origin, but if I move it up 1, it no longer has rotational symmetry, but it wouldn't be through the origin anymore. It would be around this point. And if I flip this upside down, we would then see it going through this point. So a translation up and down will kill it to a neither function, and that's what this is here. This is going to be a neither function. So sine without a translation is odd. A sine with a translation up or down is neither. And this graph h of x they gave us is clearly symmetrical on the y-axis, so that's an even function there too. So remember these things here. This is really important to know this information. Graphically, we see the symmetry, the reflection or rotation for even and odd. But also sometimes they'll give you equations like this. Remember, if it's all even exponents, including constants, that's even. And if it's all odd exponents, it's odd. If it's a mixture of both, if it's, x cubed plus 2x squared, that would be considered neither. So, all right, let's see. We got f of x is odd, g of x is neither, and h of x is even. And that would be choice 3. Okay, so this is Algebra 2 Trig Regents State Sample Question number 2. See ya.